So we're given x y prime minus x cubed cosine of x equals y. So before we even start on this one, we actually have to clean this up, get it to where all of our y's are on the same side, and all of our x's on the other side if we can. We already know we can't because I told you, but we'll try, because we always want to make it separable if we can. But let's start by cleaning this up. So we want to get this into our general form. So we're going to subtract y over to this side. We're going to add all this cosine stuff and x cubed to the other side. So we have x times y prime minus y is equal to x to the cubed cosine of x. And now we have to isolate our x prime. And we have to do that because the general form states that this dy cannot have any coefficient. Okay, so we're going to divide everything by x. So we're going to get y prime minus y over x is equal to, now x cubed divided by x is of course just going to be x squared. And then we have cosine of x. Okay, this is in the form we want for non-separable, where we have to use the integration factor. So let's identify all of our pieces. So we have our dy dx, that's good. The coefficient's 1, that's good. We're doing the right thing so far. Now our p of x is going to be the function here that's multiplying by the y. So in our case, we get negative 1 over x times y. So our p of x is negative 1 over x. Okay, and then our f of x is just whatever's on the right side. So in this case, it's x squared cosine of x. Okay, now the way the integration factor works is we need to take e to the integral of px dx. And we're going to take that and we're going to multiply it across everything. We'll get there in a second. But let's start with this piece. So we have this is going to be equal e to the integral of negative 1 over x dx. Now the negative 1 just comes out, it's a scalar, and that's an integral, so that's normal stuff. The integral of 1 over x we already know is natural log. So we have equals e to the negative natural log of x. And then when you're doing the integration factor, you don't need to worry about plus c. I know it's habit to write it there. It won't hurt anything if you do, it's totally fine. But here's where people make a lot of mistakes on this one. So when you're canceling your natural log and your e, whatever's inside the natural log comes down, but not what's outside. So that means that this is going to turn into x to the negative 1 power, right? So x to the negative 1 is equal to 1 over x, which that is now our integrating factor. Okay, so I was talking about how you're going to multiply this integrating factor across the entire general equation now, and that is what we're going to do. There's two ways to write it, and the way that I think is more confusing at first, but is easier once you're used to seeing it, is going to be this form here, where we're going to take d, and then inside the d, we're going to do 1 over x times y. So we're going to have y over x, and then underneath we'll have our dx, right? And then that's equal to just our f of x times our integration factor. So that's going to be x squared cosine of x times 1 over x, right? And now we can see there's going to be cancellation here, and we can multiply our x over. Now this is separable. And that was the point. That's what we wanted. So now we have the integral of dy over x is equal to the integral of x cosine of x dx. Okay? So then this is a fundamental theorem of calculus situation here. So you have an integral times a derivative. Well, those just cancel. So you get y over x. Now on this right side, we have an integration by parts situation. So I'm going to write the tab down here. We're going to take our derivative, and we're going to take our integral. We have plus, minus, plus, derivative of x. So we're going to start with x, and then we get 1, and then we get 0. We're going to start with cosine. And then we get an integration one time, we get positive sine. And then another integration, we're going to get negative cosine. I think that's all we need. Because we're going to go across and down and across and down. So now we have x times sine. And then we have negative and negative, so that's positive. So plus cosine of x. And then we still have our plus c, right? Okay, very good. Now all we have to do, again, this is an implicit solution, because we have this x mixed in with our y. So let's get our explicit solution, where we multiply this x across. So now we get x squared sine x plus x cosine of x plus cx.